audience. Thank you, everybody, for coming in. Some of you have been coming in from different parts of the world very regularly for our monthly webinars. So thank you very much. I welcome everybody to the December webinar, which we hold every second Wednesday of the month. I thank our guest, Keith Moore. Keith is the founder and the CEO of Autoscheduler AI. And while I'll let him introduce himself, I'll just give you a perspective of why I think the topic is important. There are two things which I see happening. One is warehouses are becoming larger and more complex. So it's not uncommon to talk of warehouses which are like 500,000 square feet now. This is something very different. We were not at that space a few years back. And suddenly we are at those 5,000 square foot, million square feet warehouses. We talk about those. And the operations are becoming complex. So that's one piece of the story. And the second piece is there's so many different technologies available to help us manage this complexity, such that managing that technology also adds to its own complexity. So I had heard Keith talk at other webinars and podcasts, and my thing was this guy is a perfect person to help us sort both these problems and give us a sense of the complexity of the warehouses and the technology stack. And I talked to him, and he was kind enough to share his time with us. And so I'll hand it over to Keith and let him introduce. And one interesting thing it came out with my chat with Keith is we have a common theme emerging among all our speakers. This Keith is the third speaker who is an avid soccer fan, consistently, third consistent speaker who's an avid soccer fan. So somehow I'm gravitating to soccer people. I don't know why. And something interesting, Keith, one of the first companies he started. How old were you, Keith? 20, 21?
I think I was about 22 when I started.
Okay, his first company was on fantasy soccer for English Premier League. So yeah, that should tell you something about Keith's mindset. And with that, over to Keith.
You mean football, right?
I mean football. Yes, thank you.
Yeah. The round football.
Yeah.
Yes.
Thank you for the introduction. Thanks everybody for listening in. As I go, if folks have questions, feel free to throw them in the chat. I'm happy to address questions as they come up. I was told I have 30 minutes, so I'm going to be going pretty quickly through a lot of material. There's going to be some things I go through. So I know there's different supply chain practitioners, professors on the call. My background. So as Piyush mentioned, I'm an engineer by training. I went to University of Tennessee and moved out to Austin. I worked in control systems and test and measurement, and was doing some work on control systems with SpaceX, and realized that they were not using nearly as much data as they were creating in the sensorized systems. You're trying to land a rocket, you're using 1/100th, 1/1000th of the data that's actually being generated. And so in about 2013, 2014, I was like, man, there's got to be a better technology out there for helping people process data. That was kind of when the third resurgence of machine learning and AI was coming about. And so I jumped on that, helped launch a company here in Austin, Texas, which if you guys ever make it down here at this point, please let me know. Happy to meet up for breakfast, coffee, barbecue, which is popular down here. And so helped grow that business from a few folks in a shoebox to hundreds of people. Did the whole, if you've seen the show Silicon Valley, that was my life for a while. I had one of the best founders ever to learn from. Decided that I wanted to go and pursue kind of my own adventure, and launched Autoscheduler in 2020 with a team of fantastic supply chain professionals. This is a space I've kind of grown up in. My family's been in supply chain my whole life. I'm probably the only person in America that's vacationed to Inland Empire. And so, super passionate about the space. What I want to cover today, though, is there's a component of AI orchestration, and I am happy to dive as deeply into the AI componentry as necessary. But I think it's important as well to understand how we got where we are today. And this is something I've worked across a variety of different industries, not just supply chain, right? I've worked in finance, oil and gas, automotive, aerospace. And there's some common themes that you start to see, and there's some really distinct things you notice when you drop into the supply chain software landscape. So we're going to start there. We're going to talk about operations and how they exist. And Piyush hit the nail on the head. We're going to talk about complexity of operations inside of warehouses and facilities. We'll go into how AI planning systems work, and what we do at my company, AutoScheduler. And we'll talk about the outcomes that people generally see when you're thinking about implementing AI systems and different ways to actually think about those outcomes based on objectives for facilities. So why do we do it? We're going to do all of that I'm in Central Time, so it's 12:11 right now. Piyush, I have a hard stop at, is it 12:40 or 12,
Yes.
12:35, 12:40?
Yes, something in that range.
Okay. Well, let's get started then.
Yep.
So I want to talk a little bit about supply chain software, and folks like Greg, I know you're going to have a lot of opinions on this. So please note, this is a simplified view of the world, but I want to kind of take everybody through a journey of how supply chain software works, because I work with a lot of Fortune 500 companies, Procter & Gamble, PepsiCo, Frito-Lay, General Mills, Kimberly-Clark, and there is a lot of complexity out there, but everybody's generally running the same types of software out there. As Greg said earlier, anything that ends with an S. And so it's important to understand the different functions that all of the different softwares actually perform and how we got to the point of needing AI to begin with in this space. So the backbone of supply chain software is a software package called an ERP. And I'm going to go through this quickly because I'd imagine a lot of folks here already know this, but the ERP is the foundational system for everything. There's a few big players in the space, SAP, Oracle, Infor, and what it is responsible for doing is everything from inventory management, order management, supply chain planning, manufacturing planning, forecast generation, all of that kind of lives in an ERP, which is why if you go and look up how many software packages SAP has available, there's like 1 billion of them. It is the central supply chain technology, which is when somebody says we're upgrading our ERP, we're moving to S4, which is the latest version of SAP in the cloud. That's a huge lift and shift because you're basically pulling the backbone out of your supply chain while it's running and replacing it and hoping there are no problems. But one thing that's unique about ERP, and I along the top, you can kind of see it, is it operates at different softwares and supply chain operate at different time scales. So ERP, you're operating at years, months, days. Like the smallest unit of measure an ERP really cares about is days, which is why you have all sorts of available to promise issues inside of supply chain. And so what people realized is that ERP planning systems weren't good enough. I needed a better ability to forecast what was going to happen and plan how inventory was going to move around my network. So a whole new breed of software emerged, which is called advanced planning tools. These are your Kinaxis's, your OMPs, your O9s. And I'm using these names because I don't know if everybody understands the vendors that are out there. And these planning tools integrate with the ERP and quite literally are providing better forecasts and better plans than what the ERP would provide. You're simply taking a singular function the ERP supposedly performs and doing it slightly better. And so companies are now planning more effectively how they're going to move inventory through the network based on demand signals that they're seeing and order profiles that they're seeing from all of their customers. So that is an ERP and that is what it does. But an ERP does not execute work. So generally it's going to plan, we're going to move this inventory from node A to node B, or, we're going to ship this to Walmart on Thursday, but it doesn't actually do the brokering of transportation. And so the next system that interacts with the ERP is called the TMS, which stands for Transportation Management System. And the Transportation Management System really does two things. It books freight throughout your network, and there's all sorts of different types of freight. Like I generally speak in truckload because I do a lot of work with CPG, but you're talking rail, you're talking plane, you're talking truck, you're talking boat. You might be talking last mile, right? There's all sorts of different TMS solutions out there. Blue Yonder has one, Manhattan has one, Lean Logistics or Blue Jay or E2Open is another prevalent one in the industry. And the TMS, unlike the ERP, operates in weeks and days. So it operates at a different time scale. It takes what we think needs to be shipped around the network from the ERP, it books the freight, and then it passes that data back to the ERP. So that's what happens in a TMS. And more often than not, there's an appointment scheduling tool that says, when am I showing up at the site? That's going to live inside of the TMS, or some people have a secondary system for that. But sometimes that's not good enough either, because now I know what inventory is moving and who's moving it, but I don't necessarily know where it is at any point in time. And this whole notion of supply chain visibility got really popular at the beginning of COVID, and a sustained popularity, which is why you have companies like Project 44 and FourKites that operate what Gartner calls RTTVP platforms, which is real-time transportation visibility platforms. And what they are doing is they're telling you where your stuff is. I'm doing my best, Piyush, not to swear, at any point in time. And we're going to track every single load. So not only do you know when it was supposed to leave, you know when it left, and you know where it is, and you know how the driver's feeling, all of that data, right? So the real-time transportation visibility platform is in minutes and seconds telling you what's happening for the freight that you booked. It's all going back to the ERP. And just like the game of telephone, data is lost every time there's a hop between systems. So you guys, I mean, you guys are following. We've now booked all our freight. We're moving things throughout our network. We're delivering to our customers. But what we're not doing is we're not actually touching and handling individualized products. That's where the magic happens, right? Supply chain is a bottom-up function. At the end of the day, you need to put a box on a truck and make sure that box makes it to the end customer or onto the shelf, and you have done your job well. So for the execution piece of actually material handling, there's another system out there called a WMS, which is a warehouse management system. There are 4 major players in the WMS space. There's some really cool new ones coming out. The 4 are SAP has a WMS, Blue Yonder, Manhattan, and Kerber. There's also some really good ones like Softeon that are up and coming as well. What the WMS does is it looks at the nodes in the supply chain. So each node being a warehouse, a distribution facility, even a plant that is shipping things out to different customers, and it's doing the inventory control, what item, literally what item is going to what customer. It's doing the work management, who is doing it on what equipment, and it's doing the dock management. How are we facilitating flow through our facility? So are we, we have so many doors, what order is being worked at what door? What trip with what orders on it is being worked at what door? That is what a WMS does. And it is a highly complex system. And unlike the ERP and the TMS, which are generally operating years to days, your WMS is operating minutes to hours. Most WMSs don't have data more than 48 hours out. You don't know what you're going to do 48 hours from now inside of a warehouse management system. You just get work dumped on you from an ERP, and it is your job to consistently figure out how to make it happen. And so to support that, other softwares have started to emerge around the WMS. So something like a YMS, which stands for Yard Management System, which is not only does the WMS know what's on the dock, I need to know what's on the yard, which is the fancy term for parking lot, at every distribution facility. What trailers do I have? What are full? What need to be unloaded? I also have automation that is being introduced. So Piyush mentioned the complexity that is happening inside of these supply chains, and we'll talk a little bit more about it in a second. And your automation is not run by your WMS most often. Some people are starting to do that, but when I work with a Fortna or a Dematic, and there's some really big automation vendors, they have what's called a WES, which is a warehouse execution system. And the warehouse execution system is responsible for any of the work the WMS decides should be handled by the automation. That WES is then going to plan and sequence all of that work in the appropriate order so that it can then get passed out on the other side in the right order to deliver on whatever the WMS expects to happen, which is generally around some appointment date on when trucks need to leave. And then outside of the WMS and outside of the automation, I have a lot of people in my facilities. I was in 2 facilities yesterday that had, probably like 400 people in them each. And managing people is hard. I think everybody here who's done it knows that. And not everybody is the same. And so, sometimes you need automation to try and speed up processes. But the other thing that you want to do is you want to actually track individualized performance. You want to be able to scorecard how people are behaving what they're doing well, what they're doing poorly, and where there might be process changes or room for improvement. And that's what an LMS does, which is a labor management system. So it's responsible for labor performance management. It looks at all of the people, it looks at all of the tasks, it has standards that you work against. And it's going to say, how is every person doing against the standard for whatever task they're performing? Meaning, who's a high performer, who's a low performer, and how can management more effectively use that data to get more performance out of the execution branch of our supply chain, which is our warehouse and our warehouse management system. So these are the three most prevalent types of software that you see around the WMS. You guys can tell with this narrative, right? This is my very fast overview of different software that exist, all the way from I'm planning S&OP years out to I am telling you what task you are doing right now and when it needs to be done. There's not a lot of interoperability between these softwares. Your WMS is posting data on occasion back to the ERP to say when a trailer closed maybe, or you're doing inventory updates every 20 or 30 or 40 minutes or every day sometimes. And these are done with these technologies known as EDI, which I should know the actual acronym for what that stands for. But it's a legacy way to transfer data between all of these systems. And you've created this chaotic environment where my warehouse might be running late. I may not have the inventory I need, or I might need inventory on an inbound. And I don't know about any of that because I have no connectivity to the transportation management system, where it's not passing the right data to the ERP, which isn't passing the right data to the WMS. So what you end up with is this highly disjointed supply chain. So why are we talking about AI orchestration to begin with? It's because all of these imperfect softwares are operated by different vendors. There's not complete openness of data. And there's this massive need for from the bottom up, meaning from the task, from the case, from the pallet, which are different units of inventory. I need to know everything that's going to happen so that I can go to my planning team and tell them that a shipment to Walmart, which isn't going to be picked for the next 24 hours, is going to be late. And they can brief the customer on it, so there's no ramifications, and the supply chain keeps flowing. Because if I'm a Procter & Gamble, the supply chain doesn't stop when I've delivered it to Walmart. It has to get on a shelf, or else that's revenue I'm not going to realize, right? On-shelf availability and the end-to-end, cross-vendor, cross-shipper supply chain is the critical thing, and these softwares have to be able to talk together. So that's why we're talking about orchestration. And what we do as a company is we focus on it from the bottom up, which is all about data extensibility, process flow management, and insight into what is going to happen in the future, and enabling communication across systems. So I'm going really fast, and if there are questions, I haven't seen any yet, but I'll have the chat open just in case. So I'm going to talk about why orchestration and this whole concept of using AI has to be done from the bottom up. So I don't know if you can raise hands on here, but
you can.
You can? Okay, so by show of hands, who here has been in a distribution facility? All right, cool. We got a few. Oh, we got a lot, actually. Sorry. I see the count, which is great. So, 10 years ago, distribution used to be pretty easy. When you talked about, at the end of the day, supply chain's a flow problem. Everything is a flow problem. And inventory flow in a distribution center used to be really straightforward. It was like, okay, well, I'm going to check in a trailer at the gate. And from the gate, I'm going to bring it into the yard, again, parking lot. And from the yard, I'm going to pull that to a door. And that trailer is going to sit in a door. And then I'm going to take all of the inventory on that trailer and I'm going to unload it, probably just straight off the truck. I might have to count. I might have to do a few different things to that inventory to make sure that I've received the right inventory. There's some receiving process, and then I'm going to put it in a rack, or I'm going to bring it all the way to another staging location to ship out. So that's called cross-docking. What orders I decide to work, 10 years ago, before you had this, highly automated directed work environment, somebody would literally get a piece of paper and say, go work on this shipment. And you would just go get all the items, you'd bring it to the staging location and you load it all on the trailer. You push that out into the yard and your day was done. Now, the world doesn't work that way anymore. Even the simplest sites that operate, customers have different expectations, right? When I order something on Amazon, I have stuff that shows up in 1 to 2 hours, and I don't live in like central Austin. And So the consumer expectations have changed, retailer expectations have changed for CPGs. And so everybody is getting more demand pushed on them, not just in process flows they need to support into the building, but also how they ship SKUs to customers, right? You're seeing a lot more fulfillment and micro fulfillment, but even at a simple CPG site, you would have processes like Walmart orders in layers and cases because it's much easier for them to cross dock to their stores when it comes into their network. And so you have to account for the fact you're no longer just pulling a pallet off a rack and putting it on a truck. You're pulling a pallet off a rack and you're bringing it to some finite number of slot case pick area where I need to pick orders, and case pick is literally you're building pallets. Or layer pick, I have a custom claw or some automation that's actually doing layer pick. I might be cross-docking things more intelligently so that I'm avoiding all of this together. And I may introduce, a lot of companies are starting to look at like pre-stage. How can we work further ahead without locking up our dock space? Well, it turns out we can pick things and pre-stage them. And this is really popular with like AGVs and automation lately. And so we've started to introduce these flow zones. And all of a sudden, this simple linear process of flowing things through a distribution center ain't so linear anymore. It's much more complex. And it gets more complex when you realize there's additional levels of complexity. So, no, sorry, that was a redundant phrase. I'm going to rephrase that. It gets more complex when you realize that there are different layers that need to be accounted for when you're actually managing this work, and that you only have so much equipment that can perform each task, right? If you're moving things in the yard, you need a yard truck. You need a spotter to do that. If you're putting things in a rack, you might need a reach truck, and you only have so much MHE, so material handling equipment, at any facility. And when you're moving things, for example, in a case pick area, you might have somebody who's got a pallet jack. And so you have different people that need to be assigned to different areas on different equipment to start to perform different tasks. And then we introduce automation, right? This is where we were 5 years ago. And now it's to the point where it's like, well, shoot, I can't hire enough people. Labor is my big problem in 2022. I'm going to put in an ASRS, or I'm going to use AGVs for this particular area, or I'm going to put AutoStore over here, or even some simple, goods to picker robots. And I'm going to have 3 different zones, but some of my inventory doesn't work in them. So I'm going to have 3 different zones for goods to picker. And then I'm going to have the case pick area over there. And I'm going to have some belts over here because that's how the warehouse was set up, right? Your warehouses are quickly becoming this mishmash of process flows. I was in a facility yesterday that said for any outbound order, there's 20 to 30 unique process flows that need to be accounted for, and they all have to show up on the dock at the same time, which is really hard when you're running a grocery store and ice cream melts in 20 minutes if it's left on the dock unattended, right? So this is what people are trying to do, and this is why AI is needed. Now, how people manage that work is inside of your warehouse management system. You have this process called allocation, which is I'm going to go and I'm going to reserve inventory. So I have to have the inventory available. There's yet another layer of complexity, which means I need to make sure the inventory is in the building, potentially in a pickable slot, before I can allocate inventory, or else the WMS is going to run into an issue. I then need to make sure that the work is prioritized appropriately, so the ice cream doesn't sit on the dock for more than 20 minutes. I need to consistently be doing that to make sure that we are constantly accounting for the fact that stuff happens, right? I remember I was at a site for a cereal manufacturer, and they stacked their pallets 4 high, and there was a gigantic box of small puffy cereal. A stack of small puffy cereal that toppled over, and multiple pallets of exploded boxes of puffy cereal 7 aisles over. Productivity is going to be different when you have an event like that versus standard operation. So what you thought you were going to do 7 minutes ago is very different than what you're doing right now. And when you're accounting for the things you can't control, like the work that's being dropped in, or the new rush order that just got dropped in that needs to be executed in 3 hours, or the 7 trailers that haven't showed up when they were supposed to, or the 3 people that called in sick because the Super Bowl was last night, life gets really hard managing these facilities. So that's why AI planning systems exist. So I'm gonna go quickly through this bit because I have about 10 minutes left. I hope I've set the stage well enough for people to understand how does the software work and why is there a gap in software today? And then secondarily, inside of the warehouse, how have we introduced all of these systems, but no answers to how to solve the complexity challenge? So this is what companies are doing. And this is really where my focus has been for the past 4 years is, and I'm oversimplifying grossly. So if people have questions about the math or otherwise, feel free to throw them in the chat, or we'll have time at the end for questions as well. But what we're doing is we are pulling in all of this data. So you remember the orchestration slide earlier where it's like, we need all the data in one place. That is quite literally what needs to happen. Is I want to know when things are scheduled to arrive. I want to know what's on the yard. I want to know where inventory is. I want to know when production is running. I want to know what material handling equipment we have, what people are showing up now, and what people are scheduled to show up in the future. What does our shift schedule look like? What are the orders that are in the system right now? What are the orders that are expecting to drop in the future? Every bit of information that a person would use to map through that really complex flow on the last slide. And I am going to build a really complex AI model that is consistently looking at all of that data and trying to find optimal. So when I use the term optimal, that varies, because you can go to a site, you can go to 2 people at the same site and say, hey, if you're going to ship this trailer, would you, how many hours would you delay to get 1 additional pallet on that trailer? And you're going to get a different answer. Somebody's like, nope, we're going to cut that product and we'll ship it later. And somebody else might say, well, we'll probably delay an hour or 2, or maybe 3, or maybe 4, or if it's Walmart, we'll probably delay up to 8. But you're going to get different answers. And so what this solver is doing is this AI mathematics is consistently looking at all of this data and then trying to replicate, how do we most efficiently run a site given all of the constraints that exist. So highly configurable, we'll talk about what that looks like in a second, to create an output that says, what inventory are we shipping? What are we cutting? When will every load be ready? Where do we put each trailer? How should we be sequencing the work? And how many people need to be on everything? Again, if you have 8 different work areas with a bunch of different material handling equipment and different speeds of execution from your LMS, you need to know all of that so that you can plan the work appropriately and make sure everybody gets all of the work done at the right time to achieve whatever optimality looks like, which is generally maximize service at minimized cost. So where am I overstaffed? Where am I understaffed? All of that information. So under the hood, and this is a really simple graphic that somebody on my team said they liked, so I put it in this morning for the presentation. But under the hood, what's actually happening is you're setting up a site the same way you would think about it as a person, which is, okay, I've got so many people that can operate, and it could be a person, I call them actors, but that probably means nothing to you, which is, it could be person, could be automation, it could be anything that is capable of doing work. And those actors can operate certain equipment. And we'll say this is a manual site where you only have a reach truck, a forklift, or a pallet jack, or I think that's supposed to be a clamp truck, but we'll talk about that in a second. And then there's so many actions that need to occur. And for every single order and shipment, we know what those actions are. They don't magically change, right? The work is the work in every distribution facility. And so what you end up doing is you say, okay, well, what actors can operate what equipment? And then what actor equipment combinations can operate what tasks? And you start to build this model of saying, okay, if I want to get any pallet pick work done, I need to have a team member on a clamp truck. And I may only have 10 team members and 6 clamp trucks. So if I have 10 team members and 6 clamp trucks, I can never do more than 6 people's work in pallet pick at any point in time. It is a constraint. And so this paired with all of the other objectives and flows and constraints of the site, like how much staging space do you have? What inventory do you have? How many doors do you have available? When is production running? Do you have raw materials you need to shuttle to different locations? All of this is factored in by the AI as an input. And then the output is going to be something like this, which is, this is what you're doing. Here's how close to done you are. And this is what you need to get done in order to run an optimal site over the next 8 hours, 12 hours, 24 hours, and 48 hours. And not only is it giving you like, I need to work these loads at these times, but it's also, what is your automation doing? What are your people doing? Where do you need to budget your people appropriately so that you're getting as much work done as you possibly can, given all of the constraints. Can you, we have functionality around like communicating on loads, on why things are late, why you need to push out planning certain things, but all of this data can then be taken and automated back into the warehouse management system. So you are not only creating this AI plan that is continuously updating. We have some sites that are doing it every 10 minutes, some sites every hour, but it's consistently looking at what are you doing? What did we tell you to do? How fast are you operating? What needs to happen? What are the objectives? And here is the best you can do. So you not only, what this does for sites is you take all this complexity and you pull it out of somebody's mind onto a screen where whether you're, year 30 or day 30, you can start to orchestrate how operations occur at a site and know that all of the flows and constraints that need to happen are accounted for. I won't go too deeply into it, just given time, but the expected outcomes and what people generally see, right? There's no silver bullet for anything. I don't want to paint this as a silver bullet. This is something to help people manage complex flows. It makes life a hell of a lot easier for people that are actually making decisions in facilities. And it enables people to get the most out of automation or the complex systems that they've started to introduce over the past 10 years. But you're talking about gains in productivity at a site. So at a manual site, average is like 10 to 15%. 12.3 is the official average number across all the different sites we're running in today. If you are running an automated and a manual facility, you can get significantly more gains per head count. Productivity can go up very significantly because you're balancing. In the book, The Goal, Ali Goldbrat talks about finding your Herbie, which is what is the slowest piece of a process that kind of delays the overall sequence of execution for an operation, right? In automation, it's generally automation. You have to work at automation speed. It doesn't work faster or slower. So it's really, how do you support around it? Meaning you have a lot more capability to help companies realize the value they thought they were getting when they bought it. You're going to see, just with better planning and door optimization and inventory optimization, decrease in deadhead travel. If you're, trying to reduce carbon footprint, a lot of people find that valuable. That really manifests in productivity, though. And then the last piece, which is something that most people in warehouses don't think about enough, which is decreasing cut product. If you're managing flow of inventory through a building, you can maximize availability of outbound inventory so that you are shipping as much as possible, given all of the constraints and objectives of the site. And so decreasing that cut number, which is a controllable cut, what that ends up in is you're increasing on-shelf availability of product or direct-to-consumer availability of product, which I think the number is like a 3% increase in on-shelf availability is 1% revenue gain for big shippers. And that's like a critical thing where you could save all the labor in the world. If you're giving people 1% revenue gain, that number is going to absolutely whatever you gain in productivity in warehousing, right? This calls out back to my very first slide, the supply chain ecosystem and software ecosystem. It's bigger than any individual component of the node. And so warehouses are often underinvested in or not focused on, but a warehouse has a huge amount of control on-shelf availability, which is a direct correlation to revenue in a lot of these supply chains and in a lot of these organizations. Companies like P&G have realized that. And I think other folks are starting to catch on. Where's this going? Last thing, this is going towards a state of frictionless flow inside of any supply chain. I see a future where any chief supply chain officer can pull up a single screen. It tells them, how are all their sites operating? Where are they operating? What's at risk? What are the things they need to be aware of in the future? What do they need to go nudge their transportation team on? What do they need to nudge their planning team on? Do they need to go talk to their carriers about trailer management? All of this is in one place because you're pulling all this data into a single system. You're doing this advanced planning and AI to understand not just where are you and how has that trended over time, but where are you going to be if rates continue or if order profiles change/continue, and you get this complete center line of operations universally that can be understood at an executive level all the way down to the operator on the floor in the warehouse. So I'm going to stop to make sure we have time for questions. As you can tell, I'm very passionate about this subject. So you guys feel free to reach out to me. Find me on LinkedIn. I love talking about this stuff. So thank you very much. And with that, I guess we'll open it up for questions.
Thank you very much, Keith. This was very, very nice. I mean, you started with the broad picture and brought it up down to the narrower. So thank you very much. Yes, I have some questions for you, but before that, I'll let the audience ask whatever questions they have.
I'll go if nobody else will. Hey,
go ahead.
How you doing, Keith? It's
Great.
Greg again. You mentioned a couple of the larger player WMSs, Manhattan, Kerber, Blue Yonder. Clearly, there's a layer beneath that, and some would argue that that layer beneath that thinks that they should be in the top right quadrant. We won't argue that, but does it really matter conditionally what WMS you're looking at? I would even go so far as say something that wouldn't be considered a real WMS, like an RF Smart that's attached to NetSuite or something along those lines.
Obviously, like the tier ones are going to have different feature sets that you're not going to get in RF Smart, but you're right. You're moving towards a state where the WMS is really doing inventory control and inventory management, and a lot of the heavy thinking and planning is being managed by orchestration softwares. What I encourage people to think about, like we do a lot of work with companies that have built their own WMS, and they're like, oh, we're not sure how long we want to support it. Do we want to go buy something off the shelf? And the answer is almost universally no. Like you don't want to buy something off the shelf because what you have built is perfect for your operation. Whereas everything off the shelf is going to have some subset of capabilities you need, but it's going to be missing key features that you care about. So the world is certainly trending that way. And I think the winner of the WMS battle, if there is a winner, is going to be the one that focuses most on openness of data and availability and extensibility versus the others. That's still a huge gap that I think a lot of the shippers of the world are going to force hands on in the next 2 years.
Yeah. And that kind of opens my next question. Sorry if I'm hogging the time.
Go ahead.
Does it matter to you necessarily if it is a subscription SaaS model or an on-prem model? And I'll take Manhattan as an example, right? Their newest solution, Manhattan Active WMS, is versionless, right? It's cloud-based, versionless, doesn't have upgrades, all that. Does that really matter to you?
So long as data is available, no. But I have found different WMS vendors have different levels of data availability in their clouds. And I'm partnered with most of them, so I'm politely skirting a real answer here.
I get
it. And so that certainly influences things where there are some cloud systems that make it a real challenge to integrate. It's possible, but it goes from like days to weeks, months, depending on how it's set up.
Yeah.
Okay. Thank you. We have a question from Julie. She asked in the chat, she's asking if production schedules, or I'm assuming she's talking about warehouse schedules also. Is it created based off ERP forecasts, or how does that work?
Yeah. So I am not a planning expert by any measure, but you're generally looking at your S&OP plans and your forecasts over the next few years. Those are discretized down to months, potentially even weeks. If you have like advanced planning and demand sensing software, that's going to be layered in. Everybody has a slightly different formula that they use to get the wrong answer, which is what all forecasts are to a degree. And the production schedule is then based on that. It's what do we need to be producing and how do we need to be pushing it through the network? And companies generally lock that in at some set point of time because you have to have enough, wherever your raw materials are coming from, you need to have lead time. And that depends on company, right? If you're manufacturing here in the United States and all of the raw materials are also from the United States, you might be able to change your schedule a little bit more dynamically than somebody that's sourcing material from, China, India, Malaysia, in manufacturing here or manufacturing elsewhere. So that's going to depend by company, but yes, it generally lives in the ERP. And there's a few advanced softwares I kind of skipped over in the space as well.
Okay. I'll squeeze in with my question, which is related. Is what's the state of data availability and data accuracy? Because those two things are the first step required to implement any of these tools, right?
Yep.
So what's the state in the industry of the data availability and accuracy?
So the good news is the big four WMSs do a pretty good job of standardizing data availability. So accuracy. So and people have homegrown systems. Most companies are thinking about like a data lake at some level. Mm-hmm. And so because they've thought about it, we can kind of piggyback on that initiative and say, hey, how do we plug in? What's the right way to do that? Availability is less of a problem now. It's a lot of work sometimes because it's not easy and extensible. Accuracy is a problem where this is where we find implementations can really slow down if we say, hey, here's what we think you need to do. And they're like, oh yeah, we don't need to do that because turns out we have a spreadsheet for managing trailers in the yard. And yeah, that's not in here and this data is wrong and we're not worried about it. And so it becomes a question of like, great, is there a place that lives? Is there an automated way we can get it? And this is why you see, ideally everything's like beautiful, elegant streaming solutions or APIs. And you also have like your Excel uploads that are supported for some sites to make sure that you have the best data possible to make decisions. And at the end of the day, you have the data that the people are working with. The goal is to bring as much of it into one place and then make as good of decisions as you can, given there's generally going to be gaps in any data set.
Okay. Ishwar has a question. Guys, I've enabled all microphones, so please feel free to ask the question. So yeah, his question is, what are the new skills required as a warehouse person to survive and maybe thrive in this current environment that we are in?
Yeah. Well, I would say if you're a leader in a warehouse, being good at change management is critical because you find sites are a little bit less static, right? You have sites that would operate the same way for 30 years. That's generally not the case anymore. New software, new automation, new MHE, changes are happening consistently. And so being really good at change management and then being really good at understanding what is the right way to build SOPs or standard operating procedures around all of the data, process, automation that we've introduced. So I find that's a big gap at a lot of facilities, particularly when they roll out something like an auto scheduler. If it's not automated back into the WMS, and we say like, here's this screen that gives you all this data. They're like, oh, this is great. And they use it for research. But then if there's not a good set of SOPs, we're teams constantly going after them. And it's like, hey, we said to do these 12 things. Why didn't you do them? It's like, oh, well, I thought about it, but Jimmy's knee hurt. And so I did something else. And so discipline in building standard operating procedures is something I have found to be highly underwhelming in warehouses, but successful ones generally have pretty good SOPs.
Okay. Thank you. Other questions? Raj, do you have a question? I see your hand.
I have a question.
Yeah,
no, I don't. It is from before.
Oh,
I didn't get rid of it. Sorry.
You've been in a warehouse. Thank you, Raj.
Keith, one of the hardest part implementing new systems is the transition and training and workforce adaptation. Can you discuss a little bit how the difficulty for the labor force with the new system?
Certainly, right? You try to minimize impact. You try to understand when you're rolling AI out to something like a distribution center, right? This is a new technology. People are immediately fearful for their jobs. So you have to do two things simultaneously. You have to really understand what they're doing today. Like anybody we work with, they need to view us as a partner. We're not a vendor. We're not going in to just force software down their throats. It is, what are they doing today? How do we fit into that picture? That's kind of the first piece. And then the second piece is you need to have the discipline of change management. And I have a really awesome team that does this at AutoScheduler, but it is consistently looking, learning, and listening with customers, even after you go live with the software. Here's what we said. What did you do? Why did you do it? Do we need to change things? Is this working optimally for you? So when you do that and companies start to see you as a partner that's really trying to make their life easier, that's the big unlock for all of us. And obviously having executive sponsorship certainly helps.
I imagine your clients are really big on this issue of the transition and training.
Mhm.
and consideration of change management, because it is really difficult on the labor.
Absolutely. And I think the best are, not everybody is. Like I could build a list of who's great and who's not great of everybody I've worked with, but I will not because that's not fair to them. But you definitely have different levels of maturity. Folks that are better at change management generally have more successful rollouts and implementations of any software, independent of AI.
Right, right. Thank you.
One question again I have is there's a lot of noise about AI. AI is going to change everything.
Mhm.
Where do you stand on that?
It's hard to unpack. So I have a whole thing on LinkedIn that I wrote about this actually in supply chain. I don't know if I shared it with you, Piyush. I wrote it in 2023.
Okay.
So it's fairly dated, but I think stands the test of time, which is AI is going to be transformative for our industry. But when most people now are talking AI, they're thinking about Gen AI. And sorry if you hear my computer ringing.
Yeah.
So they're talking about Gen AI, and Gen AI is really well designed for image, video, and text generation, where it has a massive corpus corpus is like body of knowledge that it can train off of. So you're seeing a bunch of agents that are focused on very specific things, but Gen AI for running a supply chain's really freaking hard. Like everybody in the space knows that. You are basically fighting fires all the time. You don't have enough data because every problem you're dealing with is the new one. It's not a great RPA level task. Robotic process automation level task. And so Gen AI, particularly in supply chain, short term, it has a lot of applicability in like contracting, procurement, things where there are a big corpus of data to operate from. But in execution, so transportation management and relationship management and warehouse management, it's going to be a long number of years before it's mature enough to truly take over operations. For the next 2 to 3 years, it's going to be supplemental, right? We have Gen AI that will tell people, well, why'd the plan do this? Well, it turns out you would have cut 7 products over here if you hadn't made this decision. And so being able to, distill information, it can do very well today. But that's always an adjacency to the active execution.
Right. Thank you. Ishwar, did you have a question?
Yeah, thank you, Piyush. Hi, Keith. This is Ishwar this side. With implementation of AI, can we prevent stockout situations like how we had during COVID? The kind of situation where people were struggling to get tissues, and then can we have more when you mentioned about transportation, can we have something called like sustainable route planning or sustainable route maps where we can minimize the carbon emissions and provide services to customers at lesser cost? Will the technology help in that direction? And also make these kind of technologies more cost effective for companies to implement within their organizations. Thank you.
Certainly to a degree. I'm going to kind of skate around the first question. Like, could we avoid stockouts? And I don't think short-term AI is going to really help there. There are too many moving pieces and cross-system integrations required to do that well. And that always comes down to forecasting really well. And people don't do that, right? It's been 2,000 some odd years of people forecasting things, and we're still bad at it. AI is slightly better. And I think I might actually have a patent in forecasting with like deep learning. I think I do. It does marginally better than existing systems, but it's not a godsend, right? It's not so magical it gets the answer right every time. It uses data historically. So to answer your question more directly, AI is going to have a huge impact on things where if you gave a person an infinite amount of time to do it well, they could. Because you're basically throwing compute at a problem that you can build boundaries around. So for the, can we reduce carbon emissions and make transportation networks more efficient? Absolutely. That is a good solvable problem. People are doing that today, right? Here in the United States, UPS, FedEx, Amazon, every single one of them has algorithms doing exactly that to operate their fleet. and they're dynamically updating based on, you know, real-time tracking. Even Google Maps or Waze to a degree kind of does it. So that one's very obtainable. The, you know, stockouts, probably a little bit of a longer pole in the tent to get that one resolved.
Okay, thank you. Kristen, do you want to ask, or should I just read your question? Okay, I'll read it.
Hi.
Oh, go ahead. Go ahead.
Hi. Thank you very much. I really enjoyed your talk. This is fascinating. Years ago, I worked in industry, working at a company by the name of Standard Textile. And when you showed the one graphic that showed all the different labor scheduling, time and motion studies, I used to do all of that manually. So if I were still working in industry, I would probably be doing that now, utilizing AI. So it was really fascinating to see how your technology fits in that space. So the question that I had for you is, it sounds like the users, the end users, the super users of this technology are very dependent on the accuracy of the information. So what mechanisms are in place to ensure the transparency and explainability around the decisions that your technology makes?
Yep. Yeah, really good question, because it's not as amazing as I would love it to be. And this is like a general topic, which is explainable AI. And how do you, the more complex these models get, the more challenging it is to explain them, unfortunately. And so actually one of the things that we've done is we've created, so this gets into like, where is Gen AI valuable, is we actually have Gen AI trained on the output of our algorithm to be able to explain in simple terms why decisions were made. Now, you're right, I run the company, I use the product all the time, I do rollouts with our team sometimes, and I'm good enough to where I can generally click around and understand, oh, hey, this, you know, this shipment's going to be late because there's not inventory availability, you're maxed out on labor, it needs automation, and that's not going to free up because it's already in progress on 8 other loads until this period of time, which is resulting in this one thing. But when you have these like multi-factor reasons that create a single outcome that people don't like, it's really hard to explain. And it's not perfect. And so it's, how do you give people the right level of information where there may not be it's not like, hey, you don't have enough labor. It's 7 things combined that have resulted in where we are. The world is a complex place. And so we're all, you know, part of what we're trying to do is always take steps towards making it more easily explainable in the most distilled way that is, you know, 80, 90, 95% of the way right, but also discernible.
That makes sense. Thank you.
I know we would have questions, but I think this is the time for hard stop. So what I would advise, if any of you have questions, please reach out to Keith directly. You have his email on the presentation here. Or if you want to, please send it to me and I'll be happy to connect you with Keith. I believe he's on LinkedIn, so it's a great way, and he's already invited you even for a barbecue in Austin. So please feel free to take him on that invite. On that note, I would love to thank Keith. Thank you very much. This was very informative. I really loved your explanations, and I'll tell you, if you ever want to consider academics, I can see you have a career on this side.
I appreciate it.
Yes. So on that note, thank you, everybody. We'll continue these webinars. You'll keep hearing from us. Please join in. Also, please send it to others in your organization. So we continue to create this community of learning, and all of us keep getting fascinated by supply chains and keep getting better at what we are doing. Thank you, everybody.
Thanks, y'all.
Thanks. Bye.
Thank you, Piyush. Thank you, Keith.
Thank you. Bye.
Thank you, Keith. Thank you.